Hello and welcome to the second Func Prog Sweden this year. So the agenda for today, we have like 3 presentations. First up is caramel, bringing in OCaml to the Erlang VM by Leandro Ostera. Second presentation is Clojure Script, React with a Hiccup by David Vujic. And last but not least, Monads in JavaScript. I promise you'll have a good time by Max Nordlund. And I'll end up with the summary and also with the schedule for the spring, for the coming meetups this spring. First, we would like to thank our video sponsor and studio sponsor, Adabeat. Adabeat is a tech consultancy company based in Stockholm. Most developers have a background in functional programming. If you want to know more about Adabeat, check them up in social media or on adabeat.com. If you will have questions for today, for the speakers or feedback to the speakers, please use the chat in the YouTube. And we will forward the questions to the speakers so they can answer them. Yes, with that said, let's start. So, first presentation. Caramel, bringing in OCaml to the Erlang VM by Leandro Ostera. I hoped I pronounced your last name correct.
That's all right, yes.
Thank you very much. Then, just going to find your presentation. The stage is yours.
Great. Look, Ma, I'm on TV.
Yay!
Is my presentation here, I guess?
Yes. Oh, sorry.
Should I like swap screens or something?
No. Oh, it is here.
There we go. Oh, it's on the other screen. Is that a problem or?
No.
All right. Yes. Hello. Hello, everyone. My name is Leandro. Yes, and I'm going to be speaking a little bit about Caramel. I'm going to show you a statically typed functional language for the Erlang VM. Which camera should I look into? That one?
One.
Okay, 1. Thank you. I'm a staff software engineer. I work on daily basis at Erlang Solutions. You can find me on Twitter. My handle is @leostera and as @ostera on GitHub as well. I run a company I founded called Abstract Machines, where I'm trying to build languages and software tools to think clearly. And one of the things I think about a lot these days is how to build software. So naturally, if I want to think clearly about building software, I need better tools to think about the software I'm building, right? So let's dive right into Caramel. There's a couple of goals, right, when you set out to build a programming language that I'm not inventing myself. This is stuff that I've learned from watching other people introduce their languages as well, like Rich Hickey or Jose Valim, right, with Clojure and Elixir. And the goals that I have with Caramel are to build an ML. I like ML languages in general, right? I like languages that have an expressive but sound type system. So, I don't want it to be as complex, as complicated, and futuristic, if you want to call it that, as Haskell or Idris. But I also don't want it to be unsound and hard to reason about like TypeScript. I want a middle ground, something pragmatic that works, right? I want the language, right, that embraces Erlang and OTP and all of the patterns. I'm going to get the water. It's over here. There you go. Sorry, camera swaps. So I want a language that's functional because I think functionally, like that's just how my brain works when I'm coding, right? I want a language that gives me immutable data and it lets me do concurrency in a type-safe way. Concurrency is already hard, right, if you are not working in a functional way. And when you do functional concurrency, like we all do in Erlang and Elixir, and I guess Clojure to some degree as well. Yes, I see someone there saying yes, cool. Adding type safety on top of that makes it even better, even easier to understand what's happening. I need a language that sort of leverages the ecosystem. So it's not a language that invents everything from scratch. It's not its own platform. I need a language that sort of builds on top of the giants, right, that have built the Beam ecosystem already, right? We have Erlang with, 20, 30 years of building libraries like OTP, right? And people like 99s, right? They have built the entire HTTP infrastructure for the Beam just in crazy good ways. And also from the Elixir world. And I want to be able to reuse all of that. So this language has to have a way of interoperating, right, with these Beam languages at zero cost, ideally. Maybe it will cost a little bit, but most of the time it has to be zero cost. I need a language that's free and open source, so everybody can join and communicate and contribute, right? Without anybody being able to sort of snatch it and do something else with it. And I need the language to be batteries included. I don't want to go hunting around for what's the best JSON library. I just want it to come with a JSON library. Done. Will there be better alternatives? Sure, guaranteed. Someone in the community is smarter than the people building the language, me, will come up with a better library for JSON, and I'm happy for that, right? But I don't want to put the burden of figuring these things out over and over and over on everyone that's using the language. So these are some of the goals that I've had for Caramel, right? I'm going to try to answer a couple of questions that I feel will give you a good grip of why the project is structured and aimed in this direction. And we'll start with the closest one. Why an OCaml? Why do you want to bring an OCaml to the beam, right? Well, OCaml has a pragmatic, sound, and proven type system. What do I mean by that? I mean that it's built, right, to let you get shit done. So it's very pragmatic. It's not going to bring a lot of theory that is really hard to grasp and put into practice. It's going to say, this is the type safety you need to make sure that what you're doing right now works, right? It's sound, so if the program does compile, you get a certain set of guarantees, right? You know that there won't be any, for example, type errors. It's a type system after all, right? But it does also give you a series of escape hatches that you can use to be more pragmatic, right? So you have, for example, external FFIs that you have to type at your own risk. So if you're calling on some Erlang code or some C code, right, and you get the types wrong, then that may crash at runtime. But everything within the language is guaranteed to not crash at runtime because of the types. And it's also proven. It's not a new type system. This is something that has, what, 25, 30 years of industrial usage. That's millions of hours and dollars being thrown at the problem, figuring out how to make the type system scale, be correct, right? I can't build a type system from scratch and just make it as good as OCaml just by myself, right? It will take a long time. But I need now the language to be there. So that's why OCaml, right? We also have other things. For example, OCaml has a very small functional core language, right? The functional parts of OCaml are super tiny. And this was crucial at the beginning because Caramel has been mainly a solo effort. It's mainly been me outside of work getting this done. Now that's changing, thankfully. Both Nico Bao and Michal Lapik, they're helping out a lot. But the fact that the language is very tiny means that there's less effort to do when you're doing the translations. And OCaml also has this really good scaling properties, right? Jane Street, just to give you an example, it's a company that builds everything they do in OCaml. Their frontends, OCaml, the backends, OCaml, ML pipelines, OCaml, command line tools, OCaml, everything is OCaml, right? And they have this massive mono repository where they have helped over the years to make sure that the compilation times are small and that the compiler works in an incremental fashion. So this really scales. If you have 10 OCaml files, ML files, or 10,000, right? You need a compiler that can handle that kind of load without unnecessarily redoing work. And it's built for that, right? It also scales great for scaling the actual code that you're using across different parts of a company or a system. Functors are a great way of saying there's a module that needs to be sort of templated over with these inputs, right? And still generate code that is type safe. So it's not really a way of doing meta programming, but it allows you to generate code dynamically that is type safe as well. And on top of that, it does have support for type safe macros. They're not macros as you're used to, like read macros on Lisp 1, right? But they allow you to do pre-processing of your code and embed other languages even in a way that when they get expanded, they're still type checked. So they have to be type safe. And the compiler itself is written to be extensible, so it's kind of nice to work with it. You have a front end, right? You have a back end of it, and then there's layers to each one of these parts, and there's a connecting sort of membrane in the middle, the typed tree, right? An AST that has already typed, that allows you to communicate between one side and the other. It's actually kind of neat, right? And I personally think that it has a rather elegant syntax. All right, so we've seen why OCaml, then why bring that language to the Erlang VM? I've been working with Erlang for maybe 7 years today. Someone might quote me and say that that's true or not, but I think it's one of the most scalable runtimes for functional languages out there, right? We've had functional languages like Clojure running on the JVM, and the JVM is great, right? That doesn't mean you can love the JVM and hate Java, for example. That's completely fine. But Erlang, I think it does give the JVM a run for its money when it comes to scaling the kind of programs that you run in Erlang, that you write for Erlang, right? It supports massive concurrency and parallelism from the get-go. So the Beam is built so that when you write a program and you write it with the concurrency primitives of the language, then it runs on 1 core or on 1,000 cores, right? Just the same. You don't have to restructure a program entirely to make it scale across different cores. It can even scale across machines if you're into that. It's optimized for low latencies, right? So it's actually built for telecom systems where you need to have sort of a rather long tail of latencies that are very, very short. And it's designed for reliability, right? The entire Erlang and OTP dogma is that you cannot get rid of failures. You need to embrace failure. And once you learn to embrace failure, you can build reliability around that, right? Joe Armstrong's thesis essentially is about that. Is how do we build software, reliable software, in the presence of errors? So all of the supervision patterns that the Erlang VM supports by default, right? You could think of them as a built-in Kubernetes, right? You have Kubernetes that says there's a pod, when it crashes, bring it back up, start everything, just make sure the entire mesh of services works. The Beam already does that. It already did that for you like 10 years ago, 20 years ago. So I think it's a good VM to target, which takes us to one of the last points, right? It's a good compilation target platform. We've seen all the languages, right, targeting before. We have Elixir, which is already a success case, right? Jose Valim has done great work in bootstrapping the language. The community has taken it so far, so forward, right? And there's new languages coming along, like Gleam from Luis Pilfold, Clojure from Juan Facorro, and then LFE from Robert Birding as well. They're all targeting the Beam. They're all bringing all of these different like syntactical level, or rather language level features to a runtime that's already kind of awesome. And lastly, OTP24 RC1 just got out, I think, a couple of hours ago. Yes, confirmation there, good. And that means we have the support for just-in-time work by Lucas Larsson. And that means that all of your programs will run just insanely fast. So it's a really good VM to target. The Erlang VM, the Beam, it's pretty hot these days to target. So that's why I'm choosing the Beam to target OCaml in this instance. So why a sound type system? You know, there's other languages targeting the Beam these days, and they're all pretty good. In fact, we're having another talk about Clojure right now, right? Which means Clojure is now targeting multiple virtual machines. You could pick whichever you want. The Beam, go for Clojure. You want the JVM, go for actual Clojure, right? And they're not type safe. They're not sound. They don't have a type system in the same way. So why a sound type system? From the get-go, it rules out a great large number of errors. So a lot of things that happen accidentally on Erlang and Elixir all the time that you cannot catch when you're sort of building or testing will be ruled out by default. There's a lot of bugs that appear because you don't have types to actually guarantee that a function is called with the right inputs. Hopefully you have a test for that. Hopefully you're exercising that path of code. Hopefully your supervision tree will actually restart that when it crashes, right? And in production it will be okay. But it will still be there, and it's something you have to deal with. Sentry alerts, not fun. I don't want that, right? If we can get rid of that, then great. Second is that a lot of things that can be represented in your program maybe shouldn't be represented, right? So I don't have a practical example right now, but there's a lot of states in which you can get in dynamic languages that a statically typed language can just say, yeah, we don't allow this. So no, you cannot set the password to empty string, for example. Or you cannot, you know, withdraw from a bank account that doesn't have this, this balance. You can put all of these constraints at a type level. Sometimes these constraints will be domain constraints. So you'll sit down and talk to your PO, and they will make sense of what needs to be encoded, and you will figure out how to translate that to the type language, and then bam, you write it as types. Can happen. You can also refactor large code bases much more easily. Sometimes I sit down and I make a change in an Erlang code base or Elixir code base, and I'm wondering, did I remember to test this? Will it be okay? And the reality is that if I don't remember and no one else in the team around me does remember, then we just need to run the software and see what happens, hope for the best. I kind of want to be able to say, well, something changed in the domain, we need to go into this type or record and change it, and just like the compiler guides me through the process. I feel a little dumb sometimes just following the type errors, but by the end of the day, when the compilation is done, then I know that that's not going to be a problem, at least not at the type level. I think I'll try to speed up a little bit, but there's some other things that I think are incredibly important, like the developer experience that a type system can help with. Just think of what TypeScript did for JavaScript. If you're using VS Code these days, most of the things that you get for free when it comes to auto-completion come through the TypeScript inference, the TypeScript engine, right? Type engine. Or for example, what IntelliJ does for Java. I wish we had something like that for the Vim. I really do. And lastly, I don't think typing by convention works very well. Like agreeing that we're going to have abstract types and we're going to be like safe and try to be careful, that just doesn't scale. I'll mess up, you'll mess up, and then we'll end up with a production bug. I don't want to wake you up in the middle of the night saying, hey, you modified this module. What happened there? I don't understand how to fix it. So I think a sound type system can help with all these things. This does not mean that you don't need to write tests, test help. This is just one more tool to build software. Building good software is hard. We need all the tools we can get. This is where I drink water. Yes. So why not write just OCaml, right? Well, OCaml has a runtime that's rather limited these days. It's multi-core OCaml is coming, but right now it's single-threaded. So when you write concurrent programs in OCaml, right, you have to sort of make cooperative scheduling with promises or futures. So you have to be careful to understand how that's going to execute and make sure that your promises are not blocking. If at any point in time you'd sort of read from a standard input and you didn't use the right function for that, then you're blocking the entire program, period. The community and the libraries, the ecosystems are incredibly good. They're really strong, but they're also very scarce. There's very few libraries compared to Elixir, for example. They're really good, but they're just less. And same for the community. There's not that many OCaml programmers around, even though they are. We exist. We are real. It's not like when you go to the Elixir Slack and you find 30,000 people just talking about stuff. The volumes, the numbers, the scales are different. All right, so last of this slides, and we get right into what Caramel actually is. Caramel is an OCaml dialect. That means that it has no mutability and no object-oriented system. So it's an OCaml, but it's not all of OCaml. It's changed. It's a reduced set of that, right? It's statically typed. We have algebraic data types. We have tuples, records, we got variants, polymorphic variants, GADTs as well, or GADs. We have full Hindley-Milner type inference, which means you're very unlikely to have to annotate your code. That kind of means type your code, the compiler figures out the types for you, which is pretty nice. We have structurally typed modules. We have functors. We've got a very lightweight FFI syntax to talk to Erlang and Elixir. And we will also have soon type-safe macros as well. So this is kind of like a very high-level overview of what you get with the language. So what's the status? Where is Caramel today? A couple of weeks ago, maybe a month ago, we released version 0.1, which means everything is still pretty much of a work in progress, right? Don't hold your breath and don't go rush into your manager saying, hey, can I write everything in Caramel today? No, maybe in a week. We'll see. So I'll do a little breakdown of the language features, the tooling, the standard library, and the documentation and manual, which I think you need to be aware. These are all of the parts that so far we've scoped out are Caramel. Caramel is not just the language, it's the tooling around it. It's the community that we're building. So what's the Caramel language? Oh, I realize the slides are kind of small. Yeah, well, the Caramel language has lists and tuples, and you can see in a little example there, and we'll post a link to the slides, right? Yep. Perfect. So that you can look at the code yourself. It has binary strings. So these are not IO lists in Erlang. Right now, these are binary strings, but they're represented as regular strings in the OCaml syntax. It has arbitrary precision integers, which OCaml doesn't have by default. You have to use external libraries. So all of the math that you're doing for your finance stuff right now, you can do it here, just like you do in Erlang, right? Without having to add any other libraries. And it's, on top of that, type-safe. And it has side effects, so it's not pure. So if you want to print out something, io.format, you can absolutely do it. It's completely fine. Very pragmatic. It has records and variants, and we see a little example here, right? It has opaque and abstract types, so you can define types for things that you don't want exposed. So the rest of your application just knows there's some type called ID. I don't know what it has inside, but of course some part of your application does know what it's inside. It has type-directed pattern matching with exhaustiveness checks. So if you do a match on some variable, you can say these are all of the possible variants or fields in the record that this input value will ever have. When you change the type, then compiler will complain, saying, "Hey, you're forgetting this and that over here and there." And the type inference in this example is figuring out that the actual type of that value is of the type action above in the example. It has a really flexible module system, right? You can nest modules inside a file. You can pass modules around. The functors, which are not illustrated here, lets you pass modules as functions of other modules. It gets a little complicated, so we're not going to get too much into that. It supports partial application and currying. So if you're into that, go ahead, do it. Just please don't do point-free programming. Or, please don't. It has tail call optimizations because it runs on the beam, so it's tail optimized, right? And functions support not just named arguments and pattern matching on the headers, but they also have default arguments. So you can have a function that says, this is the argument that I expect, this is the default value, this is the name of the argument, right? And then you can curry and do all the magic you want there, it means that you can build domain-specific languages just by using functions, which is really nice. All right, so the last thing we have about the language, I think this is the last thing, it's zero-cost interrupt. And in this tiny example, we show a module called logger, and the module just has an external definition. An external is a feature of the language to tell the compiler there will be a function at runtime, right, that will be called this, and it has this type, right? And when you compile it, if your module has only externals, the module goes away, and you end up calling the module you expected to call in Erlang. So in this example, we're sort of defining a type-safe way of calling the logger info function without actually adding any overhead to it. But it's type-safe, right? I think it's pretty cool. So when it comes to tooling, right, and I think this is really important, Caramel is right now being distributed as a single binary. It has no external dependencies. This makes it really easy to bootstrap your machine or your project with it. You just download the Caramel binary. You have everything you will ever need right there. Some tools that we're including right now are the code formatter. So you don't have to bother talking to your colleagues about how do you want to format it. No, that's built in. You compile with Caramel compile. You format your code with Caramel FMT. Done. And some things that we're working on right now is a built-in language server. So there's not another thing that you have to download and figure out if it's the right version for the right compiler. No, it comes packed in. You go Caramel LSP, and that starts the server. You're done. We're working on including a documentation generator, right? So you can say Caramel compile, and that will actually compile your documentation as well if you tell it to. And the last thing that we're looking into is including in the compilation binary, like the Caramel tool, the preprocessor, the thing that will let you embed GraphQL syntax inside of an OCaml module, right? And generate type-safe OCaml code from that GraphQL syntax. This is stuff that's already been built. It's already being used in production. I'm not coming up with any of this. The formatter, OCaml format. We borrow that, we vendor that, right? The language server, OCaml LSP, right? It works straight up with a few tweaks here and there, right? Documentation generator, OCaml doc. It works great. So I'm really just repackaging the tooling that works in the OCaml ecosystem, but getting rid of the assumptions they make about the tooling that they use, like Dune, the build system, and whatnot, and making sure that it works seamlessly with the assumptions that we're making in Caramel. For example, that it works with Mix or Rebar, which, by the way, we're working on those plugins right now. I think the Mix one is kind of usable, so if you want to give it a shot, just search for mix_caramel. I think it's even on HexPM. And the last thing that we're working on is a VS Code extension. So there's a lot of work being done in the tooling section and not just on the compiler. So I really want this language to be approachable so that you download the thing and it's like, oh, I can start building projects now. I don't have to figure all the things out. The next thing is the standard library, and that's also a huge topic. Right now we have a standard library that's sketched and modeled after the Erlang standard library, so you will find modules like ETS, right? But what we're really looking forward to do is to build a library, right, standard library that is batteries included, that is inspired by languages like Rust or Golang, that they have most of the packages you need to be up and running. We're focusing on reusing everything that we can reuse from the Elixir and Erlang ecosystems, all the high quality libraries we're trying to get from that, and making sure that it's type safe as well. So some of the things that you'll find in the standard library are core modules, like for booleans and strings and binaries and whatnot, but also collections, file system utilities, a net module that I expect will be reusing stuff like cowboy or gun under the hood, right? So you don't have to figure out which one is the best HTTP library. You just use the one that comes with the platform, which I think is the best. You can challenge me there. Please do. And other things like typed OTP, for example. Lastly, we have the Caramel manual. And the manual is another just massive piece of the ecosystem to figure out, which is how do we get people introduced to the language? How do you get started? What's the installation process? How do we write something that will let you get on board and do your things, the tasks that you need to do, fast and quick and easy, right? We have guides right now for calling Erlang and Elixir libraries from Caramel. We need to do the opposite as well. We need to figure out the references, right, to language features, how to compare it with Erlang and Elixir, so it's easy for you to say, okay, I have this code in Elixir, how do I translate that to Caramel in a way that it's safe but still kind of intuitive? We need to do all this work. So, almost done here. The future of Caramel, right? I would like, by the end of this year, to be able to write the core of a Phoenix app in Caramel without too much hassle. You said like mix Caramel and just drop a couple of ML modules there down your tree, and it kind of works. Just call it back and forth, it's fine. There's so much work to be done all over the board. We're still scoping what is it that the standard library will be like. There's open issues in the repo, so get involved there. We went from 0 to up to 12 supporters on GitHub sponsors these days, and all of that money is going straight into helping Caramel succeed, right? The first goal is underway. We're like, I don't know, 35% there. So if you have a spare dollar, go ahead. We can use it for the domain, for getting a designer and doing a cool logo for stuff like that. And I think the most important part of the future is that we're building a community. Very slowly, we're building a community. There's 2 strong contributors that we've been speaking with on Discord every other day, and we're going to start meeting every month to set the direction of Caramel, to figure out what governance will be like in the future, and just making sure that this is something that's built to last. Just like the Beam, where you write software once and it kind of runs forever. So that's all I got for you. Thank you so much. My name was Leandro, or is Leandro, and there's a couple of links here that you can use. Yeah, please.
Yes, thank you very much, Leandro.
I guess we need this.
Yeah, no, please stay. I'll do some questions for you.
Oh yeah, okay, sure.
Yeah, or I will say that we'll put all the links and stuff you had. We'll put it on the meetup page, and we'll
Absolutely.
put it. And I'll also put everything under once we publish like the YouTube video. We'll put it under there also, so people can find it.
That sounds perfect. Yes.
Yes, so you can build your community.
Our
That sounds really cool. Yeah, our community. Yeah, sounds really cool. I had one question. How
Yes.
come you got into functional programming?
That's a good question. I actually was asked that recently, and so I had been doing PHP and Ruby for some time, ages ago. And one of the things I loved about Ruby, and I hate that about PHP, was that in Ruby you have this tendency of grabbing collections of things and building these pipelines for transforming data. You have this array and the dot map, and then you pass in this block and do this thing and so on. And at some point, right, I realized that my problems in general were always the same. Build an API, move some JSON data to a database and out and back into the web. And I felt like I needed bigger problems. And I figured no one's going to hire me to solve bigger problems if at least I don't know the tools used to solve bigger problems. WhatsApp was around that time booming, saying like we have, I don't know, 25, 30 engineers and like 1 billion users. What's WhatsApp built in? Erlang. Maybe I'll teach myself Erlang. And I found that the connection between building pipelines that transform data and Erlang, even though syntactically kind of awkward, is still there conceptually. So I just jumped into FB after that.
Yeah. So that's your way into functional programming.
Yeah, I needed bigger problems.
Thank you very much again.
Thank you so much
You're
for having me.
welcome. Yes.